Welcome back, students. Awesome to still have you with us. So what did we do again? We looked at some nets, remember? We looked at the nets and we talked about how these nets were made up of polygons and how these nets came together to form solids. Good, and today we're looking at total surface area. What is that again? It is all the area that is covered on a solid. So if you can see, remember when I was trying to show you on the diagram on the screen how this type of cuboid had three pairs of congruent faces? Let's look at it a little bit more. So this face is A, that means this face is also A. We have a B face here. We have a B face here. C is here. And we also have a C here. So let's make that C correct there. So you have three pairs. My fingers touching a pair. My fingers are touching a pair here. And my fingers are touching a pair here. So we have three pairs of congruent faces. This one is not a cube, but it is a cuboid. So let's see. So that explains why we have, this one would be, well, if I had to label the sides. So since I didn't label the sides, it would be this side multiplied by this, because you'd have to go back to your fundamentals where you now look at the area of this rectangle or square, whatever that shape is of the face. So you'd have to remember those fundamental concepts that you would have learned prior to total surface area. So we're going to look at another activity. Now, you're a party store owner, recently purchased a cylindrical gas tank to store helium. You know how it is. You have lots of balloons and you have to have your own helium to make sure that when they come for their party stuff, you are able to fill up all your balloons. You are hired to paint. So you're not the owner. You're the person who is now hired to paint that helium tank because the owner refuses to waste his or her money. So to prevent rusting, you're going to have to install this tank, but you're going to paint it first. What would you need to know about the tank in order to purchase the minimum amount of paint to cover all the surfaces of the fuel tank? You thought about it? Awesome. So tell me what it is. Yes, of course. The total surface area of the tank is what we need to consider. So, as you know, a cylinder, which this looks pretty much like the tank. So the cylinder has this curved surface and it has what? As you can see, it has, if I were to set it like this is a circular face and another circular face. So it has circle for this face and a circle for this and this curved one. Now let's look at this question a little bit more. Do you know how to calculate the total surface area of a cylinder? I know you do. But first we're going to look at the net. Let's just look at it together. Let's look at the net of this particular solid. As we pointed out before, it consists of two circles. And if I were to cut one side and open it up and lay it flat like what we said initially, we would have had a rectangle. So the shapes that we're working with for this solid are circles and a rectangle. As I said, your fundamentals, your basics will have to come into play now. So you'd have to know how to find the area of a circle and the area of a rectangle. Now, very, very important, when you open up this net, you will realize that the circumference of the circle is also the length of one side of your rectangle. As you can see here, the length of the rectangle is equal to the circumference of the base. Now, what do you use to find circumference of a circle? Correct, 2 pi r. We look at 2 pi r, so 2 pi r now becomes not only the circumference of that circle, but it is now one of the sides of our rectangle. So the width of the rectangle is the height. So I'm closing up back my net. It will look like this. The height would be this measure here from the base to the top of the solid. So that is our height. And as you can see, the total surface area of the cylinder would be the area of the circle on top, the circle on the bottom, plus the area of the rectangle. And your area of a circle is pi r square. So you'd have pi r square plus pi r square. And then the area of the rectangle, as we mentioned before, one side would be 2 pi r, which is the same as the circumference, and the height of that cylinder. So if we were to simplify what we have here, we would have 2 pi r square plus, because we have pi r square here, plus another pi r square. When you add those, you'd get 2 pi r square plus 2 pi r h. And if we were to factorize what is common between these two terms, our expression would be 2 pi r, and what we'd have left is r from here and h from there. So this now becomes your simplified formula for finding the total surface area of your cylindrical gas tank. So just to let you know, total surface area is practical, it's real. It just depends on what you'd want to find out in real life. So I know a lot of times we think that, you know, math is abstract, but math is very practical. And every concept has its place. So total surface area could be used if you were a painter. Now, as you can see here, this is just now to let you see exactly where we're coming from. Your radius is here, and you would have been given these, or you'd have been asked to determine them depending on the question. All right, so we're going to move to activity 3. But before we go to activity 3, remember to send your questions to us on Twitter at Television Jamaica, JAM, and Facebook at Television Jamaica using the hashtag TVJSchoolsNotOut. We'll be going on a short break. See you in a few. Welcome back, everyone. Now, just for those who are just joining, let's look at what we were doing before we left. We were looking at total surface area. We were looking at how to find the total surface area of solids. And we would have said that we'd need to identify the faces of that solid and then determine the area of each face. And it is a totaling of all those faces that would give us the total surface area of a solid. We also spoke about how practical and meaningful it is for engineers, for persons who decorate things that are solids. So they would have to be able to determine the total surface area in order to purchase material. So those are just some of the applicable ways in which the concept of total surface area can be used. Even if we're looking at total surface area for a plane shape, we would look at, for a two-dimensional shape, for instance, your floor. How many tiles would be used to cover this floor? Has to do with the total surface area of that two-dimensional shape. However, let us continue and look at activity 3. Now, this is a sample question from the CSEC curriculum. We have 2 diagrams here. And as you can see, the diagrams are cylindrical. So let's read. The diagram not drawn to scale shows 2 cylindrical water tanks, A and B. Tank B has a base diameter of 8 meters and a height of 5 meters. Okay, I don't really want you to see that yet. So let's look at it. If you were asked to find the total surface area of this cylinder, of cylinder B, what would you do? Remember what we said? We said that in order to find the total surface area of a solid, we'd have to determine the faces that are there. Remember earlier we looked at the net of a cylinder. Can you tell me how that net look again? Good. So we'd have, not drawn to scale, but we'd have a circle and we'd have a rectangle. So, and we'd have another circle, that's correct. So we'd have the top and the base of the cylinder. We'd need to find the area of the circle. Who remembers how to find the area of a circle? Great. So the area of a circle can be found by using this formula. That's supposed to be a 2. It looks a little bit weird. Let's change that. So 2. Now on the question, normally the pi, what the value of pi is given. So we're going to use pi to be 3.14. So if we're using pi to be 3.14, we'd substitute the value. Now what is the radius of this? Remember it's B, so B has 5 for the height and 8 for the diameter. So what is the radius in this case? Remember now, the radius is half the diameter. So we know that if the diameter is equal to 8 meters, then the radius is correct. It's 4 meters. It's half the diameter. Great. So let's substitute. So we'd have 3.14 for pi, and we'd have to multiply the radius by itself because that's what that square means. So we'd have 4 meters. Whoops, that's not 4. That's 3. 4 meters multiplied by 4 meters. So we'd have, that is how we find the area of the circle. What would that work out to be? So we know 4 times 4 multiplied by itself is 16. So we can rewrite it, or we can do all the multiplication at once. So this would be 16 meters squared. And area is measured in a squared unit. So we'd calculate that and we'll get that there, which we'll do shortly. So we will find, so we have the area of, we're not even going to do this. I'm going to show it to you in total, but for now, so this would give us the area of one circle. But we have how many circles in this particular solid? We have 2 circles. Therefore, we're going to have to give you 2 multiplied by whatever we're going to use for one circle. And that would give us the area of the circular part, or the circle faces. Let me say it correctly. The circle face, the circular faces that we have, this would have given us the area for that. But that's not it all. That's not all. We now have this curved surface that is opened up into a rectangle. And for this one, remember what we said. This length is also the circumference of this. So how do we find the circumference of a circle? We can use 2 pi r, or we can use pi d. Correct? So, and then this length would have been our height. So because it's a rectangle, we know it's length times width, or side multiplied by the other side, or the right. So let's go 2 pi r, and we're going to multiply that by height. And we would substitute the values into the equation again, or into the expression to give us the value that we're looking for. So we put that multiplied by the radius, and the radius is the same, multiplied by the height, which is, we're given the height to be 5 meters. So we now multiply. It's only one rectangle. So we'd add what we get here and what we get here to give us the total surface area. So now let's look at it. Oh. That is if you are finding the area of the entire cylinder. And so let's write up what our total surface area is. There is a shorter way to write out total surface area, which I'm sure you guys are aware of. We tend to write TSA. So where TSA would equal whatever this works out to be, the value of this expression. Whoops. So we'd have 2314.4, or pi value, multiplied by 16 meters squared, plus, so we're going to put this into a bigger bracket, plus the area of the rectangle, which can be calculated using these values. 4 meter multiplied by 5 meter. And when you sum those two, you'd have gotten your TSA, which is your total surface area for the cylinder. Now let's look if you're given something else. So if you're given the area of A to be 314 meters squared, calculate the length of the radius of tank A. So we just worked out the total surface area of tank B because we're given the diameter and we're given the height. So we're given all the lengths and the measurements, for that cylinder, and we could work out its total surface area. Now what if you're not given the measurements, as you can see in diagram A, but you're given the area of the base. Now remember, the base is a circle. So I'm going to take this off the board. Give me a minute. There you go. We're going to take this off and we're going to look at what the area so you're given, this is fine. So you're told that the area of the base, remember what the base is? What shape is the base? The base is a circle. We're just going to put it in bracket here. The area of the base is equal to 314 squared meters. Okay? So what is the area of the base? It is 314 squared meter. What is a formula? How do we find the area of a base, of a circle? It is pi r square. What do we do here? What are they asking us to do again? They're asking us to calculate the length of the radius. So the r in our expression here would represent the radius. So we have, if we were to plug in all the values over here, it would give you this value. So we can now equate it and we can transpose for r. So we're going to transpose. We already know that the value for pi is 3.14. We don't have a value for r. We place it back. That's not right. It's 314 squared meter. Excuse me. Now let's look. So what is happening to this r squared here? It's been multiplied by 3.14. We want the r all by itself because we're trying to make r the subject of this equation. So the opposite of multiplication, as what is being done here, now is division. So we are going to divide both sides by 3.14 because we want r all by itself. We want r to stand on its own. So 3.14 divided by 3.14 gives us 1. 314 square meter divided by, yes, divide by 3.14 will give us, yes, it's 100 meter squared. And now this is equal to r squared. Is it r squared that we're looking for? No, we're looking for r. So we'll have to find the square root of both 100 meters squared and r squared. The square root of 100 is 10. The square root of m squared is m, which equals to r. So r is plus or minus 10, as you can see on the screen, or 10 meters. All right, we will be going on a short break. Thank you very much for tuning in.